So this course is really about two things. The first is just solving equations, and more exotic equations the further we go, right? So we're learning some more advanced algebra techniques that allow you to solve problems. The second, and really the more important aspect of this course, is the features of functions. Okay, so families of functions have consistent properties, and as we'll see, those properties connect to phenomena that we can model them with, right? So if I use a quadratic equation to model, in this case, profit, the properties of the equation are going to relate to this situation of selling an iPhone app in particular ways. Okay, so that's why it's useful to study these properties, and for me, it's important that you can connect these properties to real life. Otherwise, there's really no point in learning about them, right? They're not very useful to you. So if we're developing an app here, we might want to know certain things about how we set the price. Your first instinct might be to set the price as high as you possibly can, but if you set the price too high, people aren't going to buy it, right? So there's some kind of sweet spot for price, and that's what we're going to investigate using this model. So the question here is, what price should you set? And to make the question a little bit easier, I've given you the graph of the function with some key points labeled. So in this model, we have p of x is my y, right? And then x is my x, of course. And x is the price I set. P is the profit that I make. So if x is my price and p is my profit, what I am looking for when I set my price, I can choose any x. I want to choose the x with the highest y value, right? So I want to set my price to be $25. And that's because it's a maximum. There's a maximum of this function at the point 25, 112.5. And what that means, right, is that when I set a price of $25, my profit is $112. Okay? Any other price that I pick is obviously lower than that based on the graph. For example, if I pick this point right here, my profit is only $60, and that's worse than $112. So we're going to continue to examine the features of this graph and connect them to this idea of maximizing profit in this situation. So where is profit equal to 0? Well, these are my x-intercepts, right? So p of x equals 0. These are my x-intercepts that I'm already familiar with. So that's at x equals 10, or 10, 0, and x equals. So those are those 3 points now that I've given you. Okay, so these correspond to specific features. I'm going to give you the names of these features as we go. And here are our first two features, right? So we have the vertex, which is our maximum, or if our parabola is facing the other way, it could be a minimum value, right? But it's its highest or lowest point. And then our x-intercepts, which is our points where the graph touches the x-axis that we're familiar with our work previously, right? Our next two now are intervals, and we want to know, and this might be useful to know, right, if you were selling this app, interval when profit is increasing and interval when profit is decreasing. So graphically, this has to do with the slope of the graph. So you're mostly used to thinking of slope linearly, right? So positive slope is up and to the right, negative slope is down and to the right. And that is exactly what increasing and decreasing intervals are, right? So profit is increasing, while it looks like for everywhere up until x equals 25. So my interval is actually going to be from negative infinity, 25, to say everything less than 25 is an increasing interval, even though it doesn't make sense to set a price of negative infinity, right? My profit is decreasing then on the downhill portion of the graph. So that's from 25, okay? So anywhere I set my price to the right of the vertex, profit is decreasing. Anywhere I set my price to the left of the vertex, profit is increasing. And notice my interval does not include 25. I use a parentheses there because my function is neither increasing or decreasing at that top point, right? It is just kind of constant. Okay, so here these are called increasing and decreasing intervals. And I like to connect these ideas to the idea of slope, which you guys are familiar with, and of going uphill versus downhill as we travel to the right, even though we live in possibly the flattest city in the world. Okay, on which intervals are you making money and which intervals are you losing money? This is a little bit harder to think about. So making money really means your profit is positive, right? You're making more than $0. Losing money means your profit is negative. You're making less than $0. So anywhere we are above the x-axis, my profit is positive, right? Because positive numbers are up here. So that is from this particular x value to this particular x value. So on the interval 10, 40 is when I am making money, right? Because that's where I'm above the x-axis. And then losing money, there's two intervals. So if I set a price less than 10, I'm losing money. So the way I'd represent that is from negative infinity to 10, I'm losing money. And from 40, if I set a price bigger than 40, nobody buys my app and I'm losing money. 40. So positive and negative intervals, it's easy to confuse them with increasing and decreasing intervals. So make sure your notes are very accurate here. So increasing and decreasing has to do with the slope of the graph. Positive or negative has to do with whether we're above or below the x-axis. And notice as you're taking these notes, each of these examples corresponds with one of my definitions. All right, so make sure you're lining these up as I go. So those are some features of a quadratic graph. Make sure you have these notes captured. The main idea here is that these features are useful because they correspond with the situation we're modeling, right? So increasing and decreasing profit is going to help you set the price in this situation. If we're talking about maximums, and we go back to our projectile motion examples, the maximum, right, is going to be your maximum height. So these have really useful real-world connections. We're going to move on to show you a trick on your calculator to find this vertex. Make sure you have the notes here. So the way we're going to investigate a lot of this is graphically. Next year, when you take calculus, you'll learn some non-graphical methods to tackle questions like this. But here we're going to rely on our graphing calculator as a tool. So I've asked you to graph this, so I clicked y equals, and then I typed in my function as I see it. And then I'm going to hit graph. And it says to find the vertex using a graphing calculator. So here's how you do that. This is super useful. So I'm going to go second, calc. And then here, remember my graph looked like this. So I'm looking for a minimum value. If it were the other way, opening downward, I'd want a maximum. So again, second, calc, and I'm going to go to minimum. And then you need to tell your calculator where to look. So left bound, you want to pick any point to the left of where you can see that minimum is. So over here is fine. Right bound is over here. Any point to the right of that minimum. And then it's going to be like guess, and then you're going to hit enter one more time. And then I get -4. So make sure you can reproduce that result on your calculator. Again, the steps are to type it into the grapher, and then second, calc, max or min, and then you follow the prompts. So let's see what the connection is here, right? So my vertex is at -4, -4. Notice my points are -4, -4. I have two 4s that show up in my function. Okay. So when the function is written this way, this is called vertex form. The vertex actually shows up in the equation. So this is useful to recognize. So if you have a quadratic written this way with this parentheses squared, then it has a vertex at h, k, right? And notice there's a minus in my form here. So that's why I have a +4 in my equation, but a -4 in my vertex. Okay, so this is useful to recognize, and then start to learn these graphing features of your calculator is going to be really helpful throughout the course to sort of analyze these features of the function.